Okay, so this is section 2, part 2, exterior angles of polygons. First of all, by definition, an exterior angle of a polygon is when any side of a polygon is extended. And you get an exterior angle. So I have a diagram here for you. All right, so here's a triangle, and I extended this side. When I extend that side, this little area here, this space, that is an exterior angle. If I was to extend another side here, then this would be my exterior angle in this space. And then extending the third side down, I could as well. Okay? So if the shape has 3 sides, it has 3 exterior angles. If the shape has 4 sides, it has 4 exterior angles. So in Schoology, if you would please, go to the folder for today. Have a physical calculator ready to go. Going to the folder for today. Scrolling down, it says exterior angle investigation. Exterior angle investigation. Click on that page, and then there are 4 links. So these are preset shapes in GeoGebra. So you can click on the first link for quadrilateral. If the shape is too large or too small, you can zoom in and out over this space here with 2 fingers, and it kind of, or scroll with 2 fingers on your trackpad and it'll zoom out, make it a little bit smaller. So these green angles here, they are exterior angles. Would you please add them up with your calculator? Once you get a sum, go back to Schoology, click Pentagon. Add up these 5 angles. When you're done adding up those 5 angles, go back to Schoology again and click on hexagon. And the last one, heptagon with 7 sides. What are we finding? The exterior angles of all polygons add up to what? 360. Did you think that was going to happen? The first one was quadrilateral. We probably thought, oh, 360, that's what the interior was. Were we a little bit shocked when it was 360 for the pentagon? Okay, and then it kept happening. Okay, so if we go back there quick, and let's say I zoom all the way out, or I keep going, what shape does this form? A circle. And what do we know about circles? They add up to 360. So if you kept zooming in, and so that makes sense then that all those exteriors would have to equal 360. Okay? So going back to finish this out then, what mathematics can we do here? So first of all, the theorem is the exterior angles equal 360 degrees. So when we're working with an exterior problem like number 1, it says find the value of x. It's a little bit easier than the interior angle problem because I don't have to figure out what the exterior equals. What is this equation going to be set equal to? 360. So let's combine like terms. In your calculator, add up. 67, 96, 59, and 86. Should get 308, right? And then to solve that problem, we would subtract 308 from both sides. And the value of x is 52. Example number 2. Again, no front work to be done. We know that our equation's just simply going to equal 360. However, let's look to combine like terms. We have a 3x and a 4x, which is going to make 7x. And then if we add up 93, 46, 62, and 47, because those would be like term constants, that would be 248. Simple two-step equation to solve. Subtract 248 from both sides. Divide both sides by 7. The x in this problem has a value of 16. Go ahead and take a minute here and get number 3 set up, please. Go ahead and check. When you added up all of the x's, we should have got 52x. All of these constants, 204. Again, set equal to 360. Subtract 204 from both sides. Divide by 52. X equals 3. On this next example, number 4, we only have one exterior angle in the picture, and we have a triangle here. What do we know about exterior angles and interior angles like this? They should what? Add up to 180. That would be a linear pair. We'll focus on those a lot more here later in the unit. So let's say that we called that little angle y. We know that 110 plus y would need to equal 180. Okay? So subtract 110 from both sides. We know that this piece here, the third angle of that triangle, is 70. So not a super complex problem, but we had a purpose for this example. Okay, so this piece here is 70. Then to finish out this problem, obviously, we would then go back to our interior angle objective. 80 plus 70 plus x would need to equal 180 because we know that the interior of a triangle equals 180. And so x would have a value of 30. So if I'm going back to, or let's say I look at example number 5. Example number 5 is a regular polygon. Okay? Regular polygons have equal interior angles. What do you think that means for their exterior angles if the shape is regular? They have to be equal, and it is proven here in the linear pair situation. So let's say every angle was 70. Well, every exterior angle would have to be 110. So that's what we're filling in here. So interior angles are equal of regular polygons. Interior angles and exterior angles at each vertex are supplementary. That's your term for adding up to 180 or a linear pair. Therefore, the exterior angles of a regular polygon are equal. So to simply find each, we know that all the exterior equals 360. All we have to do is divide by x, or the number of sides. So then here on example 5, we would need to count up and see how many sides are in this picture, or in this polygon, and that is what? How many? 7 sides, okay? So what mathematics do we need to do? 360 divided by 7. So we get 51.4 degrees. I saw that answer, I thought, I don't know if that's quite right. That doesn't seem right. So then I thought, okay, well, what if I go and check my interior angles? My interior angle is 7, so that rule again was n minus 2 times 180, right? So I did n minus 2 times 180, and then I divided by 7, and I got 128.6. So then I added my 128.6 and my 51.4, and what should I have got? 180. So second guessed myself a little bit when I did this problem, and so I checked and made sure that that did actually work, so it made sense. Okay? All right, last example, number 6. What if you just have words? The problem even comes simpler. You don't even have to count the sides. Oh, that's pretty yellow there. What is each exterior angle of a dodecagon? 12 sides. 360 divided by 12, 30 degrees. Okay, so that concludes our exterior angle notes.